So, machine learning, it's a term you hear thrown around constantly, right? But what does it really mean? Well, today we're going to pull back the curtain on that buzzword. We're going to get right to the heart of a pretty wild question. How do computers actually learn?
And really, this is the big question, isn't it? It's the one that drives the whole field. I mean, think about it. If you're not sitting there writing code for every single possibility, how in the world does a machine figure out what to do? That's the puzzle we're going to piece together today.
All right, so here's how we're going to tackle this. First, what is machine learning? Then we'll look at the three main ways it learns. We'll dive into supervised learning, touch on the other two, and finally see how this all goes from just data to a real-world app. Okay, let's jump right in. Section 1. What are we even talking about when we say machine learning? Let's get to the big idea. Okay, so here's the absolute core of it. Instead of a programmer writing a giant, endless list of if-then rules for every situation, machine learning, well, it lets the computer figure out the rules on its own. All we have to do is feed it a whole bunch of data. You can think of it like a person learning from experience, except a computer can process millions of experiences in seconds.
And this is where things get really cool, because it completely flips traditional programming on its head. For decades, programming was, you give the computer the rules, you give it the data, and it spits out the answers. But with machine learning, you give it the data and the answers, and you ask the computer to figure out the rules. It's a total game changer in how we approach problems.
All right, section 2. So how do machines actually do this learning? Well, they've got a kind of toolkit with three main approaches. And here they are. You've got supervised learning, which is kind of like learning with a teacher. Then there's unsupervised learning, where it has to find patterns all by itself. And finally, reinforcement learning, which is all about learning from mistakes, trial and error. Okay, let's dive a little deeper into that first one, supervised learning. This is really the workhorse of the entire field, the one you'll see used most often. The flashcard analogy is perfect here. You're basically showing the computer a massive stack of flashcards. On one side is a picture, and on the other is the label, the correct answer. So you show it thousands of pictures labeled cat and thousands labeled dog. And because it always has that correct answer to check against, it starts to figure out the patterns, pointy ears, whiskers, that kind of thing, all by itself. Now, this whole approach really breaks down into two main kinds of jobs. The first is classification. That's all about putting things into categories or buckets. Think, is this email spam or not spam? It's a simple choice. The second job is regression. And that's when you're trying to predict a specific number. What's the temperature going to be tomorrow? Or what will this house sell for? But the key for both is that they start with data that already has the right answers. All right, that was supervised. Now for a quick look at the other two toolkits in our arsenal, unsupervised and reinforcement learning. So unsupervised learning is what happens when you don't have the answers ahead of time. You just dump a massive pile of data on the computer and say, find something interesting in here. It's like being a detective with no clues, just looking for hidden groups or strange patterns. And then you've got reinforcement learning. This is basically how you train an AI to play a game. The model tries something, say a move in chess. If it's a good move, it gets a reward. Bad move, it gets a penalty. Over millions of tries, it teaches itself the best strategy to win. Okay, so we've got the theory down. But how does this all go from being an idea to something you can actually use? Well, it's not magic. It's a really clear, structured process. That's the key thing to remember. Machine learning isn't magic. It's a form of engineering. There's a clear pipeline that takes messy, raw data and turns it into a useful tool, something like the recommendation engine on your favorite streaming service. And this is what that pipeline generally looks like. First, you have to pre-process the data. That means cleaning it up, getting it ready. And it's funny, this part can be like 80% of the entire job. After that, you do some analysis to look for interesting patterns. Then comes the big test. You evaluate the model to see if it actually works. And finally, if it passes the tests, you deploy it. You put it out there in the real world. I really like this quote because it captures the true ambition behind all of this. We're not just trying to build faster calculators here. The ultimate goal is to build systems that can understand and learn from data in a way that starts to look a lot like how we do it. So if you're going to remember just one thing from all of this, let it be this. Machine learning is about a huge shift in thinking. We've gone from programming with rules, telling a computer exactly what to do, to teaching it with data and letting it figure out the how all on its own.
And that really leaves us with a final, massive question to think about. As these machines get better and better at learning, the conversation changes. It's not so much, can a machine learn to do this anymore? The real question is, what problems should we ask them to solve next? What are the most important, the most challenging, the most beneficial things we can point this incredible tool at? And the answer to that, well, that's what's going to shape our future.